Greetings dear viewers. In this video, I would like to explain about centrifugation is a separation method which uses the action of centrifugal force to accelerate sedimentation of particles in a solid liquid mixture. Sedimentation is the deposition of particles suspended in a liquid medium to the bottom of the container according to their density and size. For example, when water with suspended particles of varying sizes and densities is left undisturbed in a container, the process of sedimentation due to gravitational force would occur. As a result, particles of higher density would settle faster to the bottom than particles of lesser density. If a medium other than water is used, such as glycerol or castor oil, the rate of sedimentation will be reduced. It is because of the higher viscosity of the medium. Sedimentation process. The sedimentation process is dependent on the density and size of the suspended particles, the viscosity of the medium in which the particles are suspended, and the gravitational pull. The gravitational force under normal condition is about 980 cm per square. This sedimentation process, due to the force of gravity, takes very long time, and the process is generally incomplete. If the liquid with the suspended particle is subjected to centrifugal force, which is several thousand times greater than the gravitational force, the sedimentation process can be completed in a short time. The instrument that is used to apply the centrifugal force to a solution with suspended material is a centrifuge. Centripetal force. The force that maintains an object in a circular motion is called centripetal force. That is, force seeking to move towards the center. If no force is exerted on an object, it tends to move in a straight line at a constant speed. In the same object, in order to deviate it from the straight line to a circular path, a centripetal force must be applied at right angles to the object's velocity. The centripetal force causes a corresponding centripetal acceleration, which is also towards the center. Centrifugal force. According to the Newton's third law, for every force of action, there is an equal and opposite reaction force. Thus, the force that is equal and opposite to the centripetal force applied to an object moving in a circular path around the center is the centrifugal force, meaning a force tending to move away from the center. The existence of a centrifugal force is not real. The centrifugal force is imagined as a force acting on an object moving in a circular path. It tends to pull the object away from the center, and that is a force which equals and thus balances the centripetal force that pulls the object towards the center. The centrifugal force is directly proportional to the speed of rotation, that is angular velocity, and the radius of the rotation. That is, higher the angular velocity and the radius, greater will be the centrifugal force. It can be expressed as centrifugal force is equal to angular velocity square into radius. That is, F is equal to omega square into R. Relative centrifugal force. The centrifugal force F is divided by 980. It is actually the Earth's gravitational force, which is generally referred to as the relative centrifugal force or RCF, which means the number of times of gravitational units. Thus, mathematically, it can be expressed as RCF is equal to omega square into R divided by 980 into gravitational units. Thus, RCF is dependent on RPM and radius. The radius of rotation R is also constant for a given centrifuge, and therefore RPM is the only factor which determines the RCF. The speed of a centrifuge can be expressed in RPM or RCF, but RCF is a better expression. Sedimentation coefficient. The sedimentation rate of a particle expressed per unit of centrifugal field is called sedimentation coefficient. It is expressed in Swedberg unit, that is S it is equal to V by omega square into R, where S is the sedimentation coefficient, V is the sedimentation rate, omega is the angular velocity, and R is the radius of rotation. The value of 1 Swedberg unit is 1 into 10 power minus 13 second. The sedimentation coefficient standardized for a medium of water at a temperature of 20 degrees Celsius is referred to as sedimentation constant or standard sedimentation coefficient. The value of S for a particle or molecule, its size and its sedimentation rate are generally directly proportional. That is, larger the S sedimentation value, larger the molecular size and faster the sedimentation rate. Centrifuge. A centrifuge is a mechanical device used for separating substances of different densities using the principle of centrifugal force. A common centrifuge is a container that is revolved at high speeds. The principle of separation is similar to that of sedimentation by gravity. Sedimentation of particles by gravity at high speeds driven by centripetal and centrifugal forces results from the rotation of liquid in the container. The separation or sedimentation of particle in a centrifuge is based on its size, density and viscosity of the medium. This is affected by a force that is 1000 to 1 lakh times that of gravity. Basically, the centrifuge is constructed with a rotor and a motor, which is connected by a central shaft which has at the distal end provisions for holding the container. The shaft is connected to a motor which can be operated at different speeds. Types of centrifuges. Based on the requirements of separation of particles in a larger volume, the centrifuges may range from simple hand centrifuge to highly sophisticated analytical ultracentrifuges, namely desktop or clinical centrifuges, high-speed centrifuges, ultracentrifuges, analytical ultracentrifuges. Desktop or clinical centrifuges, which are simple designs either with swinging bucket or fixed angle rotors. They have a maximum speed of about 3000 rpm with a relative centrifugal force of 7000 G. Their applications include the preparation of serum from whole blood and separation of RBCs, yeast cells, etc. Second one is the high-speed centrifuges, in which they have about 25,000 to 30,000 rpm, a centrifugal force of about 90,000 G and refrigeration facility to function in low temperatures from 0 to 4 degrees Celsius are used for cell fractionation, that is, to isolate cellular organelles like nuclei, mitochondria, etc., and to isolate and collect microorganisms and precipitates of chemical reactions, antigen antibody reactions, etc. Third one is the ultracentrifuges. These ultracentrifuges are capable of operating at very high speeds of about 75,000 rpm with a centrifugal force of about 5 lakh G. Obviously, the rotor chamber is fully refrigerated, that is from 0 degrees Celsius to 4 degrees Celsius, and evacuated to counter and minimize the heat generated due to friction between the spinning rotor and an ambient air. Ultracentrifuges are useful for the separation and collection in pure form of cellular organelles and macromolecules. The fourth one is the analytical ultracentrifuge, which are more powerful than the preparative ultracentrifuges in the sense that they have a built-in optical system to measure the sedimentation characteristics of the macromolecules in the centrifuge. They are useful for measurement of sedimentation coefficients and molecular weights of macromolecules. Thank you for your patient listening. Kindly subscribe and share maximum. Thank you.